Hello friends, in today's session I'll take you through another important topic of reasoning, which is cubes and cuboids. So you generally encounter a few questions from either cubes or cuboids. So let me take you through that. So I hope we know what is a cube or we know the difference between a cube and a cuboid. Both cube and cuboid are 3D figures. So in cube, let's say this is a cube. Why? Because in this case, length, width and height is equal. So let's say this is n, this is n, this is n. So the volume of this cube will come out to be equal to n into n into n. So this is n cube. While in case of cuboid, if I want to draw a cuboid, this is what it is. This is the length, this is the height and this is the breadth. So the volume in this case comes out to be L into V into H. That means if all the three dimensions become equal, it becomes a cube, else it is a cuboid. Right? And one more thing. Either in cube or in cuboid, we have edges. This is called an edge. This is an edge. This is an edge. Or we have face or surface. So in any cube or cuboid, we will have 6 surfaces. 1, 2, 3. 1 top, 1 bottom. 1 front, 1 back and 2 sides. So number of surfaces are going to be equal to 6. And in any cube or cuboid, the number of edges. So this is an edge. This is a vertical edge, vertical edge, vertical edge, vertical edge. So there will be 4 vertical, 1, 2, 3, 4, 4 horizontal top and 4 horizontal bottom. So they are going to be 12 edges. So in any cube or cuboid, there are going to be 6 surfaces and 12 edges. This is something that you must know. This is a simple concept on cubes and cuboids that will help you to solve the questions on cubes and cuboids. So taking it forward from here, the kind of question that you will encounter in exams will be, let's say you have been given a cube. This was a cube which was of, let's say, some dimension, n into n into n. And you have divided this into smaller cubes of let's say you have divided into smaller 125 cubes, which is 5 into 5 into 5, 125. Fine. So you have only made cuts and you have divided into 125 cubes. Now this entire bigger cube is in one piece right now, and now you have colored all 6 surfaces of this cube. Colored all 6 surfaces of this cubes with some color, let's say red color. Fine. And now after coloring it, when it is dried, you have divided, bifurcated, and all these 125 cubes are lying in front of you, the smaller cubes of dimension, let's say 1 each. So these are smaller cubes of dimension 1 each, 1 by 1 by 1, the smaller cubes, and they are lying in front of you. So fine. Now the question that can be asked to you, that out of those 125 smaller cubes which you have made from the bigger cube, how many cubes will have 3 sides painted, 2 sides painted, 1 side painted, or no sides painted? Fine. So this is something that you normally encounter, and this is a simple question and can be done easily by generalizing things also. If I talk about cubes with 3 sides painted, so we know that they are going to be there on the edges. This is an edge. Corner edge, in fact. This is a corner edge, 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 4 at the top and 4 at the bottom. So the answer to this is going to be nothing but 8. So there will be 8 such cubes, wherein the 8 such smaller cubes which will have 3 sides painted. Right? If I talk about this number of smaller cubes with 2 sides painted, so 2 sides painted are going to be there on the edges, like for example this edge, or this edge, or this edge, or this edge. You will have to think logically and also visualize it. So if I talk about this edge, wherein I am saying that there are 2 sides painted, I will have to discard this and this, because this is a cube which is having 1, 2, 3 sides painted. So the remaining that will have 2 sides painted will be on, if I talk about in one edge, it is going to be 1, this one, 2 and 3. So in one edge, you are having 3 cubes which are having 2 sides painted. And I have already told you that the number of edges that you have in a cube are 12. So if one edge there are 3, so in 12 edges there are going to be 12 into 3, which is nothing but 36 cubes. So the answer to this will come out to be equal to 36. I'll explain again. Let's say if I would have taken this edge. Now this from top to bottom, this top and the bottom one is having 1, 2 and the back side, front, bottom and the back side, 3 sides painted. While if I talk about this cube, this or this is having 2 sides painted. So this will happen for this edge, backward, 4 at the top and 4 at the bottom, and you'll end up getting your answer as 36. So this is how you do it. Now if I talk about cubes with one side painted. Now one side painted are always going to be there on the surface, but leaving aside the cubes which are there on the edges. Let's say for example, on the surface if I talk about this one, or this one, or this one. So these are cubes which are having one side painted. Similarly this. So in one edge, the number of dots that I have made are 9, 3 into 3. So in one, not edge but surface, on one surface, I have 9 cubes which are having one side painted. And I have already told you that the number of surfaces or in one cube are nothing but 6. So in each of these 6 surfaces, you will have 9 cubes with one side painted. So your answer will come out to be 9 into 6, which is nothing but 54 cubes. So this will come out to be equal to 54 cubes. Now comes the turn of the last one, which is number of cubes with 0 side painted. Now if I remove the outer shell of this cube, which is 5 into 5 into 5. Outer shell, what I mean by that is, if I remove the top and the bottom, this side and this side, and front and back. So that means I have removed this entire layer, top and bottom layer, and sides. So that means what I left in between will be a cube which will be of 3 by 3 by 3 cube, which is nothing but equal to 27 cubes. So this is what it is. Now this is from the understanding perspective, but if I want to go for a shortcut to this, that can also be done very easily. I'll try to tell you that even. Number of cubes with 3 sides painted are always going to be on the corner edges, so that will remain intact as 8. Number of cubes with 2 sides painted are going to be there on the edges, as I have told you. Number of edges are 12. Fine. And in one edge, if I talk about number of cubes with 2 sides painted, I'll have to discard this and this. That means I'll have to discard 2. So if in one edge there are n, I'll have to discard 2 out of it. So number of cubes with 2 sides painted is going to be n minus 2. This will be there in one edge and it will be there for all the edges, and number of edges are 12. So the generalized form for this will come out to be 12 into n minus 2. So that means if my cube would have been of 7 by 7 by 7 and I would have divided into smaller cubes of 7 into 7 into 7, and I wanted to find number of cubes with 2 sides painted, on one edge I would have discarded the first and the last one. That means out of 7, if I have subtracted 2, I will be left with 5, n minus 2, and in this case is 7, 7 minus 2 is 5. So this is 5 on one edge and number of edges are 12. So 12 into 5, which will be the number of cubes with 2 sides painted in that case. Similarly, if I talk about cubes with one side painted, as I told you that are going to be there on the surface. On one surface, if I talk about this surface, I don't want the top portion of it. The reason being the top portion is having either 2 or 3 sides. I don't even want the bottom portion. I don't even, because bottom portion is also having either 2, this is 2, 2, 2 and this is 3, 3, 3. I don't even want this one because this is also having either 2 or 3 and this one. That means initially when I was checking, when I want to take from here number of cubes, so initially I was taking n into n. Now I will be taking one less from both the sides, which is nothing but n minus 2 this side and n minus 2 this side. So which is coming out to be n minus 2 whole square. And this is going to be there for one surface, and the number of surfaces are nothing but 6. So this will come out to be equal to 6 into n minus 2 whole square. So if it was 7 by 7 by 7 cube, So I won't have taken, so initially it was 7 by 7 in one surface, now it would have been 5 into 5. And that will be multiplied with number of surfaces, which is nothing but 6. That will give you your answer. Now comes the last one, where in case you are supposed to find the number of cubes with 0 side painted. The number of cubes in your case was 5 into 5 into 5. Fine. Now I want cubes which are having no sides painted. So that means when I am talking about, when I was taking 5 or n from here, now I neither want this side nor this side. That means I only want this middle portion. That means I want to subtract 2 from n. Similarly, I neither want the top or the bottom. That means what I want from here is n minus 2. And I neither want in this also the back and the front. That means what I want is n minus 2. So this will come out to be equal to n minus 2 into n minus 2 into n minus 2, which is nothing but n minus 2 whole cube. So the direct ready-made formula for this is n minus 2 whole cube. You simply need to put the value of n and try to find the answer to these questions. So this is what you are supposed to apply at the time of an examination if you encounter anything of this kind. More you practice, better you become. Thank you so much.